This session, we will learn about deadlocks caused by semaphores. We all know semaphore is going to prevent race conditions. But apart from that, improper use of semaphores leads to deadlock. So, as there are many advantages with the semaphore, the problem with deadlocks. If you use semaphores well, there is no issue at all. But whenever there is improper use of semaphores, then there may be a chance of deadlock. And that too, there should be a condition that minimum number of semaphores supposed to be 2 to identify there is a deadlock exists just by using a concept of semaphores. So a semaphore is a synchronization mechanism used to control access to a shared resource in a concurrent system. So especially the main objective of implementation of semaphores is nothing but to avoid race conditions, because race conditions leads to inconsistency and incorrect results. So while semaphores help prevent race conditions, and incorrect use of semaphores can lead to deadlocks. So the one important point is that semaphore does not cause deadlocks themselves. Improper ordering, wait operations and semaphore signal operations in the semaphore causes deadlocks. So what is a deadlock? You may repeat the previous classes which I already taught. So deadlock is a situation where two processes are waiting for a resource indefinite waiting time. So in this case, the resource X is assigned to P1 and P1 is requesting for Ry, and Ry is assigned to P2 and P2 is requesting for Rx, and which leads to a situation called a cycle in this RAG. So RAG is nothing but resource allocation graph. Then this is leads to a concept called deadlock. You want to say that deadlock exists, there are mandatory conditions like mutual exclusion and no preemption and hold and wait and circular wait. All the four conditions supposed to be applied to say that there is a deadlock in the system. So our target is how the semaphore causes a deadlocks just by processors improper uses of semaphores. Assumption there is a semaphore 1 and there is a semaphore 2. I already told you minimum number of semaphores required to establish a deadlock is 2 minimum. So semaphore is a control variable which is initially with a 1. So in this case, two processes, process P1 and process P2, they are trying to use the semaphores. You want to use a semaphore, there is a mandatory requirement that first of all, semaphores must perform wait function. If it is successful, then you will go to critical section. While leaving, we are going to use a signal function. This is mandatory in order to use a semaphore in a good manner. So process P1 is asking for wait of ES1. Then after that wait of ES2, two semaphores. And after that critical section. Then while leaving signal of ES2 and signal of ES1. So process 2, if you look at other side, wait of ES2, wait of ES1, critical section, then signal of ES1 and signal of ES2. If you observe this piece of code, it looks like a normal semaphore, how the wait and signal functions are being used. But if you observe keenly and in deep, you will see that there is a dangerous situation among the processors may occur. So let us say if I am using semaphores, wait of S1, wait of S1 means it is decremented, wait function decrements the value by 1, it becomes 0. So understand that first P1 is initiated the transaction. Then after that wait of S2, it cross check S2 value is initially 1. Therefore, wait also reduces semaphore 2 because two semaphores, they are not a single semaphore. Understand carefully. Process 1 trying to implement a double semaphore concept in this case. Then when these two operations are successful, immediately it enters into the critical section. While releasing the critical section, you need to use a signal function so that it will be reminder to other process to access the semaphores. Otherwise, if you just leave the critical section without signal function, the values of semaphores will be zeros only. So other process cannot able to utilize the semaphores well. That's why wait and signal functions are mandatory. So while leaving, S2 becomes 0 becomes 1 because signal is going to perform plus. And here also S1 becomes 0 becomes 1. So normal execution, I have not performed any kind of preemptions here. Now you see after that process 2 begins. Then process 2, the S2 becomes a 1, then 1 becomes a 0. And wait S1, again 1 becomes 0. Then it enters into critical section. And while releasing signal of S1, then S1 is initially is 1 and it resets to 0 here because P2 is using a wait function. Then while releasing a S1, then 0 becomes a 1 and here also 0 becomes 1. Then S2 and S1 values are normalized to its initial values. No problem whatsoever in this case. But so I have not performed any kind of preemptions here. Observe, if a P1 followed by P2, that means P1 executed, after that P2 executed, no issue at all, and no deadlock at all. No issue and no deadlock concept. And even if P2 begins initially and P1 goes, here also no issue and no deadlock in this case. But when you give the preemptions, then you may think of about a deadlock carefully. So let us prove that these two processes are fall into deadlock. How? Let me explain. So I'm taking initially S1 is equal to 1, S2 is equal to 1, both are semaphores. Now process P1 begins execution wait of S1. Then after that P1 is anticipating for wait of S2 because two semaphore would like to use. After that it enters into critical section. While releasing, it says that signal of S2 and signal of S1. So P2 wait of S2 and wait of S1 critical section and signal of S1 and signal of S2. What will happen if I run this code? This is what is presented here. Signal of S2, signal of S1, signal of S1, signal of S2. Signal of S1, signal of S2, signal of S2 and signal of S1. Now let me write step by step. Please observe keenly. Step number 1, P1 started. You may also start P2, I don't mind. P1 started and saying wait of S1, then 1 becomes 0. So S1 is now available to P1. Now in the meanwhile, P2 preempt P1. Then chance got to P2 this time. P1 under pause. Now P2 started. Now P2 is taking care here wait of S2 because its first statement is wait of S2 only. Its first statement is wait of S2. So S1 value already it is set to 0 by P1. Now S2 it is setting 1 becomes 0. It is available. So wait function is successful for P2 as well as wait function is successful for P1. So it's a fine. So far it's a fine, no issue. Then after that, please observe. Then after that, P1 preempt P2. See this. See the magic. P1 preempts P2. This time who will get the chance? Obviously P1. Again P1 is continuing. It's not started, already it is started. P1 is continuing. P1 continuing from where it is paused. Where it is paused? Exactly here it is paused. This is the line where you see that the P1 got paused by P2 because it is preempted. So P1 continuing from next line. What is the next line? It is asking for wait of S2. Unfortunately, wait of S2 becomes unsuccessful because already P2 made S2 becomes what? 0. We already utilized wait function on S2. So it's already in 0. Now we know the condition of semaphore. While S dot value less than is equal to 0, then it's supposed to be under a do skip. Please revise wait and signal functions in earlier classes. So therefore, so 0, as you find the 0, then automatically P1 will be under waiting. P1 will be waiting for signal. Observe carefully. For signal of S2, somebody has to give 1 because it's 0. Now who got the chance? Let us say that chance goes to this time P2 because it's under waiting in this case. In this case, it is under waiting. P2 is under waiting. So in this case, P1 is under waiting. Now P2 got a chance. So P2 continuing. P2 continuing. When P2 continuing, it is continuing from this line. So what is the line it is thinking about? So it wants to ask for weight of S1. Weight of S1. But what is the weight of S1? It is trying to reduce, but no, it is not possible because already S dot value is equal to how much? 0. Again, weight condition. Inside weight, there is a while condition is there. While S dot value less than is equal to 0, do skip. Then therefore, this guy cannot able to make it a successful down. Successful down is nothing but a what? The weight operation should be decremented by 1. So here it is not successful down. Both are unsuccessful. Now in this case, waiting for signal by somebody for S1. Here P1 is waiting for signal for somebody S2. That's it. They blocked each other. How they blocked? How they blocked is, this is your semaphore 1. This is your semaphore 2. Observe carefully. Semaphore 1 already given access to P1 and semaphore 2 already given access to P2. Now in the second line, both are desiring for what? P1 is desiring for S2 semaphore. It is requesting, but it is not possible because S2 is already assigned to P2. Unless P2 give signal function onto S2, that S2 is not available to anybody else because already it is locked. Now this is under waiting and this is under holding. Now here also P2 is trying to request for S1. It is not possible because S1 is already assigned to P1. Therefore, here also the process P2 is under waiting for S1 by holding semaphore 2. That's it. This is formed a cycle, hence it is a what? Deadlock. So blindly, if at all examiner asks you by seeing the piece of code, now you are in a position to say the answer. What is that? If there are two semaphores by name S1 is equal to 1 and S2 is equal to 1, you have to use first wait function for S1. Then you have to use for wait function for S2. You can't cross this line as a first. You can't cross this line as a second. That is what is happened in the previous code. So the order of semaphores there and here is supposed to be what? Same. So this leads to deadlock. So what is the solution? The correct solution is ordering of semaphores is very, very important. This is improper use of semaphore. This is a incorrect use of semaphore. Incorrect use of semaphore. So what is the solution? The solution is correct use of semaphore. How to use the correct use of semaphore? It's nothing but order you have to follow. What is the order? P1 and P2. There are two semaphores by name 1 and 2. Both supposed to target 1 only. Both supposed to target 1. Don't make ulta. So both S1, S1. Then after that what? weight of S2. Here also it's supposed to be in ascending order, weight of S2. So let us give now preemptions. Line number 1, P1 started, then in this case what happened? Weight of S1, then 1 becomes 0. Now second line, P1, that means P2 preempts. P2 preempts P1, then who got the chance? P2 got the chance. And P2 is asking first line. What is the first line? Weight of S1. It is not possible. You are underwear, waiting only. Then what is going to happen? Unless you got the first line successful, you can't go for second line. That's it. Then who got the chance? P1 only. And P1 is asking for what? S2. P1 continue in this case because S1 is right now it is with what? P1. So P1 continue. He also performed the second line, that is weight of S2. S2 is empty because it is not started by P2. Earlier it is not like that. Earlier it is not like that because of what? First of all, this guy is used 2, then it is waiting for 1. And this guy is already started with 1 and waiting for 2. But now I am making the order. So in this case, wait to S2. S2 is freely available. Then 1 becomes 0. Then P1 finally in the what? Critical section. That's it. So even you give the preemptions either from P2 to P1 or P1 to P2 or P2 initiated the transaction, it never minds. As you are using the number carefully, 1 followed by 2 and 1 followed by 2, then it is better. Otherwise, 2 followed by 1. Decremental also no issue. So in this case, it is a what? No deadlock. Because the first line and first line same, second line and second line same. If you jumble the order of using the semaphores, then it may be a deadlock concept. The same I explained. So P1 execute wait S1, acquires S1. P2 is asking for acquires S2. Yeah. So P1 got control on S1 and P2 got control on S2. Now, P1 execute waits S2. It is not possible because already it is with whom? It is with whom? P2. And P2 is asking for what? S1. It is with whom? P1. Then it leads to deadlock. So P1 waits for S2 and P2 waits for S1 forever. It leads to deadlock. It's a never-ending process. The deadlock existence like this. In the first line, wait of S1 got by P1 successfully. S2 got by P2 successfully. And when S2 is asking, it is not possible. When S1 is asking, it is not possible because somebody is hold already, then it leads to a deadlock. How to prevent deadlock? Maintain the semaphores in either ascending or descending. So wait S1, wait S2, wait S1, wait S2. When you see uniform utilization of numbers of a semaphore, it never leads to a deadlock. That's a blind answer you can write. That means if there is a semaphore A and semaphore B and semaphore C, which is using by P1, P2 also supposed to use semaphore A, semaphore B and semaphore C. You can't make a twist among them. This twist will give you a concept of a deadlock. Don't change the order of the semaphores. So this is another example. There are 3 semaphores by name A, B, C. Semaphores. There are 3 semaphores are there by name A, B, C, and all of them initial values are 1. P1 is using a P. P is nothing but wait function. And P1 is using B, wait B. P is nothing but wait only. And it is also performed C. So here also, if it is A, B, C, and if it is A, B, C, you never mind. You never get a concept of deadlock. But P2 twisted it. P2 twisted it. So this is got, if at all, P1 got semaphore A. And in this case, A cannot be utilized by P2 and A cannot be utilized by P3. Observe carefully because they have started semaphore A carefully. When A is not down by P2 and P3, they cannot go for C and B because unless the first line is successful, you can't go for a second line. In this case, you never see a concept of deadlock. Let us see now. So if at all, let P1 begins. When P1 begins, it is taking weight of A. Weight of A means 1 becomes 0 and P2 preempt. P2 preempt P1. In this case, P2 got a chance. Now what P2 is saying, I want to get down. That is weight of A. So you can't get down because already somebody is already got down. Therefore, it is not possible. You will be underweighting. Suppose P3 is underweight. So P3 preempts P1. So here also you can't get down because already the semaphore value is decremented by P1. Therefore, unless the first one is down, you can't go for next lines. So even though you performed a twist here, it is no problem because the first semaphore is blocking you. So in this case, you say that there is no deadlock existence. So when you say deadlock, if I change the order, P1 and P2 and P3, three semaphores, weight of A, then here I say weight of B, then here I say weight of C. See, the three different stories. P1 is controlling A, P2 is controlling B, and P3 is controlling C because as they are the first lines. Now it is asking for P2 this time. So P1 is looking for B, P of B, and P2 is looking for P of C, and P3 is looking for P of A. It's not possible because already you're controlled these three and you're requesting for this, it is not possible, and you're requesting for this, it is not possible, and you're requesting for this, it is not possible. Then P1 and P2 and P3 followed by P3 goes to P1 request leads to circular weight. So in this case, it leads to a concept of what? Deadlocks. So remember, dear friends, semaphore does not give deadlocks wantedly. Improper order of using of semaphores leads to a deadlock. So what is the solution I said? The solution is if semaphores are orderly used weight functions. If semaphore orderly uses a weight function for a process not, other process also supposed to use semaphores in the same order. If you follow this, there is no deadlock. So please subscribe the channel and give your valuable comments for better development of the video lectures.